It's one thing to listen to doom and gloom about food and fertilizer shortages, skyrocketing prices, the cost of living, or your job being outsourced overseas or eliminated due to automation. It's quite another thing to hear practical, immediately actionable advice from experts who can help you reduce the fear, anxiety, and burden of these problems. Tune in now to the Surviving Hard Times podcast from the Finding Genius Foundation with Richard Jacobs. Before we begin, a note from our sponsor. I'm Richard Jacobs, Executive Director of the nonprofit Finding Genius Foundation and host of the Finding Genius podcast. In late 2016, I was rear-ended at 65 miles an hour by a truck on the highway, which sent me off-road into a ditch. The impact of the collision gave me a concussion and other injuries. At the hospital, a CT scan showed that I had thyroid nodules, which turned out to be cancer. It was then, when I had a biopsy of my neck, that I realized even if I was a millionaire, I wouldn't want a second or a third biopsy due to the pain and the invasiveness of it. And appointments at that time for thyroid experts were 3 to 6 months out, and I was worried about dying now, even if that was irrational. So because of this, I've decided to raise money to conduct a literature review on steroids, on the causes of anxiety and depression, a condition that affects well over 50 million people in the United States and hundreds of millions worldwide. Our goal is to create a codex, a guide that reveals all possible treatments for anxiety and depression for people that live with the condition or for loved ones that have it, as my wife and my son do. To find out more about our fundraiser, visit findinggeniusfoundation.org and click on current initiatives. And now to our guest. Hello, this is Richard Jacobs with the Surviving Hard Times podcast, sponsored by the Finding Genius Foundation.
Hello, this is Richard Jacobs. My guest is Graham Stewart. He's what's called the EVP at FIBRE52, FIBRE52. We're going to talk about how cotton has been processed pretty much the same way for 80 years. And Graham has come up with a sustainable solution to bleaching and dyeing cotton. So we're going to talk about that and more. Welcome to the podcast, Graham. Thank you.
Hey, thank you too. It's great to be here. And yeah, thanks for inviting me on your pod.
Yeah, no problem. I saw in your bio, you've been in the cotton industry for like 40 plus years. Very, very long time. What's a bit about your background? Like, how did you get interested in this field and what have you done in your career?
Yeah, Richard, I started over 40 years ago. I think I kind of had to be in this industry, in the textile industry. It wasn't just cotton. I was born in a wool town. Where I lived was the largest dye stuff maker in the world, Imperial Chemical Industries. They invented many of the dyes that are used today, and particularly when we come into talking about cotton. The reactive dyes were invented by ICI, 200 yards from where I lived. And that was back in the 1950s, and those are the biggest group of dye stuff used on cotton today. And they've evolved a bit, but, the basic chemistry is the same. So I kind of had to be in this business because the town had 100 mills. And where I was born, we were actually a mill house, and all my family worked there, or you could either work in the dye stuff making operation or you could work in the mills. And that was about it in my town. So that's what attracted me, was the fact that the dye stuff was being made so closely. And that attracted me to chemistry. So when I left school, I went straight to study dyeing and chemistry.
Interesting. So cotton, what is the process by which it is grown, harvested, and then turned into the various clothing that we wear? Maybe just a quick overview of it for folks that don't know.
Yeah, I'm not involved in the agriculture in cotton, but I do know a little bit. Of course, cotton does come under scrutiny because there's a lot of water use, chemicals, pesticides, which is getting very quickly cleaned up. There's no doubt about it. But cotton is demanding for water, and we'll come on to, why that affects FIBRE52, or what FIBRE52 can do for that in the whole supply chain, I should say. But cotton is grown in certain parts of the world. We're fortunate here in that America has such a rich heritage in cotton. And my partners are based in Houston, Texas. Texas is the largest grower of cotton in America, and I believe it accounts for about 50% of America's cotton. So the cotton growing industry is still large here. Other areas would be China, India, Egypt, different qualities. And where we really come in with FIBRE52 is where cotton begins to be processed. So it goes from its raw state when it's been collected into what we call a cotton gin. That ginned product goes to a spinner to spin a yarn. And the largest cotton spinner in the world, Parkdale Mills, is based in America. In fact, not far from me in North Carolina. But they have big spinning plants all over the world. Fantastic.
It would be cool if they had a gin called Cotton Gin. I don't know if they do, but the name came to mind.
Well, I'd certainly drink it. Yeah.
Yeah, it'd be interesting. But okay.
Yeah, sure.
So, all right. So they'll harvest it and they'll spin it into what form? Like what are the stages again that it goes through until it becomes a garment?
In yarn form, there are different spinning methods. So the longer, stronger, more expensive cottons and the cleaner cottons are ring spun. So that's a stronger spinning system. So if you look at your fine cotton sheets, your fine cotton shirts, that's that kind of cotton. If you look at something like your average cotton sock, or a very average cotton T-shirt, I mean very average, the mass market cotton T-shirts, they're open-end spun. So the ring spuns are combed. So it's a finer way of spinning cotton. The open-end yarns are what we call carded. So they go through these huge carding machines. And usually then you're dealing with shorter cottons, less strength. And also our process gets a lot of interest there because we don't damage the cotton with the FIBRE52 process, as happens with traditional cotton. And it leaves that weaker open-end yarn in a much stronger state. It doesn't add strength, but it doesn't weaken it.
Okay.
And to answer your question, then there are many, many other stages after that. We can branch out into the textile industry, but, for apparel, there are wovens, knitted cottons, both in the T-shirt that we wear, that I wear and you wear, to the sweaters that we wear, to cotton woven pants, So, and even the upholstery, the home furnishings that we all use, cotton's a big deal there too.
Okay. So this is the process that's been going on for decades and decades, for what I believe you said 80 years in your notes?
Yeah, probably more. The cotton processing that I've studied over the years, undoubtedly cotton processing has advanced, it has evolved, but over those years, the fundamentals have stayed the same. And that is using very heavy alkali as opposed to acid, the very heavy alkali with very high pH, which damages the cotton. And the reason that high alkali is used, or heavy alkali is used, is to get what the industry lovingly calls the trash out of the cotton. So in putting caustic soda, for instance, onto cotton, which is a heavy alkali, it saponifies the waxes in the cotton, but it takes out the vegetable matter that is what's called trash in the cotton to make the cotton look cleaner. And also that's part of the bleaching process to make cotton whiter, because cottons can be even quite brown in their nature, depending on the quality of them. The better cottons tend to be whiter in the beginning, but these processes are to make cotton cleaner and whiter.
Okay. What are some of the innovations in cotton manufacture that have occurred, or there really hasn't been any? Anything with mixing with other fibers? I don't know. What are some of the innovations in it?
Yeah, you can see over the years, over the decades, where there's been other innovations in textiles. So the invention of nylon, for instance, was a big one. Cotton became blended with nylon for strength, and nylon became fashionable. Then, around the same time, the viscose rayons that are very widespread. The viscose rayons generally made from wood pulp, for instance. The bigger brands would be like Modal that you see in the big fashion stores around the world. That's cellulose, so very easy to blend with cotton. And in fact, was invented even as a replacement for cotton. The downside is that even that isn't very strong, but it's beautiful, it's soft. Then polyester came about, which was a big part of my background. With my company, we were one of the first to dye polyester. And polyester is now the largest fibre in the world by volume used. But cotton is a close second. And I haven't really thought about it. I think in volume, cotton may even be bigger than polyester, but I don't know that for sure. So, yeah, cotton and polyester are really the two largest fibers that are used around the globe.
What are preferential mixes with cotton, and what are the properties? Like if I mix cotton and polyester and I have like 5% polyester, what would that be like versus cotton and something else at a 50-50 ratio? Like, is there a much difference in material properties depending on the mix of different garments?
Yeah, there's trade-offs there. 5% wouldn't do a great deal, so probably not worth bothering with, but, it happens. Whereas, you're on the edge from a strength standpoint. Adding some polyester will help that. So you do see T-shirts with 5 and 10% added. If you go to 50%, then quite often the guys that sell cheaper performance products, so cheaper sporting goods products that you'll see in these big sporting goods stores, that again is to add strength. And, people talk about the wicking properties because polyester is not absorbent at all. So the people selling it tend to say that it wicks moisture away. Cotton is very absorbent in the way that it's processed with the heavy alkalis, but that's one thing that alkali process aims to do, is to make cotton very, very absorbent. And something we can talk about is that one of the side effects of FIBRE52, and we can do it both ways, we can make cotton absorbent in processing, or we can make it water repellent, naturally water repellent. So it can be hydrophilic absorbent or hydrophobic repellent.
Okay, interesting. What about some of the, what else can you do with the cotton, like for sportswear, where it wicks away moisture? What are some of the properties and trade-offs of the different mixes of various synthetics with cotton?
So cotton's very absorbent, which is not the greatest thing for sport. For comfort, yeah. If you're wearing it around your home, lounging around in it, sleeping on it, it's wonderful. For strength, again, that's where polyester really comes in. And for those guys who want to think that polyester is wicking moisture, that's great. But what I can tell you is that I discovered in the invention of FIBRE52, if I can call it that, was a side effect where we're not taking the natural waxes away from cotton or the natural properties away from cotton. And in that hydrophobic state, what we found, we did some big trials with NC State University, who have an amazing lab, probably one of the best, if not the best in the world. It's a comfort lab. They did a big test on our FIBRE52 versus polyester and versus traditional cotton. And what came out of that was incredible. And so some of the largest sporting goods brands in the world are working with us on FIBRE52 because what we've got is a constant comfort factor. We thought it was hydrophobic. We found that it's actually absorbing moisture and then releasing it, but it doesn't saturate. And therefore, it stays comfortable on your body, doesn't stick to your body like polyester does. And so in the tests that we did, we found that polyester starts to wick moisture very, very well. Then there's a crash, bang. And anyone who's in sport and has worn polyester in warm weather, you do know that that polyester product is going to stick to your body.
Yes.
It then sticks you fairly quickly. And that was shown in the Comfort Lab testing. And it's like Mount Everest. The graph went up as it was wicking moisture and then came down the other side just as fast. Cotton's like a little molehill in that it saturates real quick. So it cools you down to begin with. It gets rid of some moisture, but then it's so absorbent, it goes again it can be within minutes, as we probably know. If you're out there running, cycling, whatever, in humid, hot conditions, bang, sticks to your skin. FIBRE52, it went up as it wicks the moisture, and then it flatlined for an hour and a half as the moisture keeps getting expelled and taken away naturally from the body. So that was a big one and something that I didn't expect.
So where is the this new fiber mix going to be used? What do you think is the ideal application for it?
It's not a fiber mix. That's up to the manufacturers. They want to put polyester with cotton. That's fine. As far as we're concerned, what happens is we're using bioproduct to bleach and dye cotton. Cotton has to be bleached anyway to begin with to get the nice colours that we all like to wear, and to an extent, that's what we do, but with bioproducts and biocatalysts. So basically, in that processing, what we bring to cotton, which I think is quite important, is that a much faster processing time, much lower temperatures, a much gentler process that saves also an enormous amount of water, which is really important around the world. That's our big commitment to cotton. So our carbon footprint can be up to half normal cotton processing, but also the strength of cotton is normally 15 to 20% higher using the FIBRE52 process. So that's what we bring to cotton, but we also bring those performance attributes if you need them.
Cotton seems to, this is a question for you, it's kind of funny, but over the years, I've gotten some really, really big shirts and wash them, and it doesn't always happen, but when they're pure cotton, sometimes they shrink like crazy, like a third of their previous length shrinks. And where does the material go? Does the fiber just arrange in a tighter pattern, or like how does cotton shrink and why?
Yeah, that's due to the stability of the fabric. And what you'll find is, certainly in the poorer cottons and the ones that have been carded, if the dyers don't finish the cotton properly or don't have the machinery to finish, then you can get really considerable shrinkage. And you're right, Richard, that's happened to all of us, I think. I used to also be very much involved in the wool industry, where shrinkage really is a problem. And, wool has to be treated chemically to get rid of that shrinkage. In cotton, what you tend to do is to relax the cotton or the cotton fabric. So all that relaxation's gone. The problem you had is the relaxation hadn't gone. And then you put it in the washing machine and the relaxation happens, and, you give it to your younger brother because it's not going to fit you anymore.
What do they mean, relaxation?
So when a cotton's knitted, so think of your normal T-shirt, then when it goes on a knitting machine, then there are rows, you can actually see it, there are what are called wales and courses in technical terms, where the cotton is kind of plied together, cotton yarn, to form a stitch. So you're forming a stitch pattern. If that stitch pattern hasn't been compacted to stop it from shrinkage, then it's unstable. And so that instability, once it gets in your washing machine, is taken out. The result, guess what? Shrinkage, and it can be considerable.
Why does it shrink? What's happening with the cotton to cause it to shrink? And how is it restructuring?
It's not the cotton; it's the knit itself. So the knit itself is relaxing. So there's a lot of tension. When you knit something, you knit in this enormous amount of tension, and the dyers in fabric, you have to take that tension away. If it's not taken away, and it happens, that's what you're going to get. The tension disappears in your washing machine and causes shrink.
What is when cotton is, like, I'm wearing a cotton shirt right now. I'm looking at it kind of close. I see the lines in it and everything. What else is in my shirt besides cotton? Let's say it's a white shirt. Like, what is this knit you're talking about? Is it just the way the cotton is woven around itself, or is there a different material that is mixed in with the cotton?
Yeah, knits and wovens are entirely different. So your woven, your normal woven, let's say Brooks Brothers shirt, which is a beautiful shirt, doesn't shrink much because it's tightly woven. And so there is no relaxation, if you understand. A knitted shirt, the nice stretchy knitted polos that you wear, that we all wear, that's where the shrinkage exists. Back to what I've just said, if you don't take the relaxation out of the knit, the result is shrinkage. So in textile terms, it's called dimensional stability. And so when you produce cotton, you need to measure that dimensional stability, which usually means that it shouldn't shrink less than 5 or 6% in either direction. What you're getting is like 20%, 30% shrinkage. I hope that explains it, Richard, without getting too deep into the weeds. The
material must be bunching up and getting more dense. If it shrinks, let's say it shrinks like 30%. I mean, it doesn't like evaporate into thin air. So I would think like the resulting density or porosity of the cotton is a lot less because it's got to go somewhere. It shrinks into like a smaller footprint, right?
Not really. Let me give you the parallels between wool and cotton. So wool on its surface has these little barbs, right? On what's called the epicuticle of wool has these little barbs, and we've all seen it, in your granddad's sweater. You throw that in the washing machine and it felts up, right? And in the olden days, 20, 30 years ago, there was something called Total Easy Care, which was invented by the wool industry, which took the barbs off wool. Cotton doesn't have that. So cotton itself is not shrinking. Again, it's back to the physical property of a knitted cotton. That's shrinking. So it's a physical issue. And
so a normal cotton shirt is just stretched cotton, and when it shrinks, it's no longer stretched like it was. Is that right?
Correct. Spot on. Yeah, you got it, Richard.
But again, when it's in a stretched state, I would think that it's the layer of it is thinner, and once it goes to a relaxed state, it would thicken up. It wouldn't necessarily ball up, but the average thickness of the shirt, I think, would it seems like it would increase and it would get more dense.
Yeah.
The cotton that's side by side, right?
Yeah, absolutely. If you look in processing, what tends to happen on a knitted fabric is you stretch it out on a machine with pins to 60 inches wide, right? And that then you make sure that you relax that the best you can under certain conditions, and then you've taken the shrinkage out of that. However, if you don't achieve that for any reason, exactly what you say, the garment is going to be smaller, but it's going to be the same weight as the big one, right? So you've got a denser product. So you're absolutely right there.
Well, how does that change the material properties, the moisture passage, et cetera, of a relaxed versus a non-relaxed shirt, let's say?
Not much. In a normal cotton shirt, it saturates just as quickly as normal. So, maybe if you've got your very badly shrunk shirt, it will probably saturate quicker than the one that's more breathable. But that's the only difference. They're both going to saturate real quick.
Is there something that can be added to a cotton shirt in low percentage where it still has the desirable properties for wear, but the relaxation will be much less?
Yeah, you can put certain finishes onto cotton to achieve that. They tend to be environmentally unfriendly, so they are legislated against now. And I can tell you, that's my life in that in sustainable cotton processing, what we can see is that there's definitely legislation coming down the line. The regulatory landscape is continuing to evolve. And that, from an industry point of view, means, increased reporting and so on what you've got on your garment, what that does to your body, right? And a lot of those products that have been applied over the years are now not aligned. They're not allowed to be applied. And there's an organization which we're becoming a member of, which is ZDHC, which is, zero discharge. So that also monitors the chemicals on your product and also the processing. So the discharge of chemicals within processing. So you can't put those chemicals on. And, there's a lot out there about fluorocarbons, for instance, like PTFE or the non-stick pan, the non-stick pan issue. Those same chemicals are still being applied to textiles, not just cotton, and they are being legislated against in a big way. But some of them are allowed, and some are friendlier than others. The ones that wash off are friendlier than others. The ones that stay on, I think that they will soon disappear. So I hope that answers your question.
Well, actually, it brings to mind something. Some people talk about embedding sensors in clothing, and we may be going out in left field, so forgive me if we are. But would cotton be a good base layer in which to embed sensors or to do something to the cotton so that it could sense moisture or other compounds coming from sweat or whatever to become a wearable sensor? Are you working on any of that stuff or aware of it?
I'm definitely not working on any of that stuff. I've seen it in the past where I've worked with the military. For instance, wool is possibly the best, but polyester is good because it's not absorbent. But basically what you're trying to do, if you're putting electrical sensors inside a textile, it's not a good idea if that textile saturates. So I definitely wouldn't recommend knitted cotton, but woven cottons don't saturate as much. So, there is an argument for using woven cottons for that usage. And it's a good question because let's face it, that's just going to happen more and more and more as as those electronic sensors evolve.
So what's the difference between how do I know if I'm wearing woven or knit cotton? What kind of garments are made from which kind of material processing method?
So take as I said, take a shirt from a company like Brooks Brothers, where you've got these beautiful shirts that go really nice with your suit and you wear a tie with them, right, if you wish. But that's your classical cotton shirt, or the bed linens that you sleep on, which you'll often see they're advertised as 300 count or 300 thread. Some of that is not factual, but usually what they say, and I don't think it's legislated, but what usually, the higher the count, if you go from a 100 to a 300, the 300 is much finer, and those are wovens. So those are mainly woven. When you go and get your Ralph Lauren polo with a nice collar, you go play golf in it or whatever you do, go to dinner in it, and it's nice and stretchy, that's your knitted product. Also, the sweaters that you wear, which cotton sweaters are plentiful. Those beautiful cotton sweaters are stretchy and, they go over your T-shirt, for instance, and T-shirts themselves, they're all knitted. So that's the difference between the two.
So what is it? It just feels, so what feels nicer to people, woven or knitted, or does it depend on the application? Yeah. Which one feels which way and how so?
It depends on the application. It depends on the look. I mean, this is where, if you're attending a formal dinner, you're probably not going to wear your T-shirt, right? And if you want to put a tie around it, you tie with a T-shirt at a formal dinner, probably not such a great look. But if you're going casual, and you're going for a night out, or you're strolling around and you're out in the evening, your cotton T-shirt, your stretchy cotton T-shirt's fabulous, yeah. Providing it's not too hot, then you have to think of something else. But that's the difference. It's the formal look versus the informal look. And of course, woven formal shirts also look great. And, like me, I'll probably, because it's so hot here where I am tonight, if I'm meeting, somebody formally for dinner, I probably have an open neck shirt and short sleeves. That can be woven too. So not easy to explain, but the formal look and the informal look are usually different because the formal look is woven, the informal look is more often than not knitted.
Okay, so you would expect like higher quality garments to be woven and lower quality ones probably knitted.
No, not at all. I mean, so for instance, if you take beautiful Egyptian cotton shirt or a Pima cotton. In America, we grow also Supima, I think it's called, where it's a longer, beautiful staple cotton, and the diameter of the cotton is much finer, if you understand. So the diameter is smaller than the cheaper cottons. So these more expensive cottons, if you knit them, you'll probably see a beautiful sheen on them, and you're probably going to pay about $200 to $300 for your polo instead of $50, $60. But yeah, you can't differentiate on price between knitted and wovens.
Okay. I think I've got you. Interesting. So any big changes coming in the, the cotton industry, the garment industry, besides going towards more sustainable practices? Are there any, again, big innovations that you see coming?
Yeah, I think the innovations, one big innovation is actually information. When you go in a store and buy a T-shirt or a sweater or your pants, a suit, whatever, there's not that much information. Certainly going back 10 years, there wasn't that much information about where your textile comes from, both in the fabric itself and who actually made that garment and what the country of origin is. So that visibility is becoming a big deal. And so consumers are demanding that. That will be a huge change in the industry.
Okay. Well, very good. Graham, what's the best way for people to find out more about your work? Where can they go?
Yeah, FIBRE52.com. Real simple. So it's spelled FIBRE 52.com. FIBRE52.com. And what we're doing is we're putting more and more information on that website, both for industry. At the moment, we're very industry focused, but we're also putting more and more in the consumer domain, more information as we were just speaking of. And we're helping brands and manufacturers to get that information out into the public domain and out to the consumer.
Okay. Maybe you'll do your own line of special clothing instead of like Martha Stewart, it'll be Graham Stewart,
I'd love to think so, yeah. But with FIBRE52, our endeavor is to, continue with FIBRE52 in a really what is an ingredient brand, in that we're adding value to the fabrics and so on. We wouldn't go out and compete against our customers by having a FIBRE52 or a Graham Stewart brand. That's not going to happen.
Well, I'm sorry to hear it, but thank you, Graham, for coming on the podcast. It's a really interesting subject, and now I finally have solved the mystery of why my clothes shrink all the time, sometimes like multiple times. So thank you.
Yeah. Okay. Well, good wearing for the future. Hope your clothes don't shrink. And thanks for inviting me on the pod, Richard.
Before you stop listening, ask yourself, what are one or two useful things you heard on this podcast that can help you overcome food and fertilizer shortages, skyrocketing prices, the cost of living, or your job being outsourced overseas or eliminated due to automation? Please like and subscribe and tell your friends and family about their Surviving Hard Times podcast. We're all going to need help now and in the near future.